Hello students, welcome back. So now I will show you how to use grid search CV or randomized search CV to find the best machine learning model, and also I will show you how to perform hyperparameter tuning. The dataset that I will use is the wine dataset. In this dataset, the target column is has these values 0, 1, 2. That refers to the type of wine. So the first thing you're doing is you read your CSV file, you read your datawine.csv, and I'm printing the 10 random samples from that file. So these are my 10 random samples from that file right here. And this is your target column right here. By the way, if you're having trouble finding that file, you can always get this data from your scikit-learn directly. So you can uncomment this part out. Oh, let me just select everything, uncomment everything, and there you go. So in this case, you can just load the wine and just run this. This is going to load your wine, and then you convert this into your data frame, and then you print your data frame right here. So when you run this, that's going to print out your data frame. So you can get your DF like this one too, in case if you're having trouble getting that file. Okay, and now let's take a look at the shape of your data frame. So in this particular instance, I have 178 rows and 14 columns in total. So let's separate our features and labels. In this particular instance, I'm not using all the columns. I'm just using only a few of them: alcohol, malic acid, ash, alkalinity of ash, magnesium, and total phenols. These are the only columns I'll be using. So this is my features right here. So that's my X right here. My Y is my target column. That would be this column right here. So that's my Y. And then I'm printing my X and Y. So when I print X and Y, you can see that this is alcohol, malic acid, ash. Okay, so this is my X right here. And then let's come over here. And then I print out my Y, and this is my Y right there. Now let's try to find the hyperparameter the hard way. In this hard way, which is the bad way, I will be first using train test split to split my dataset, and then manually I'll be fine tuning my hyperparameters by trial and error. See which one gives me the better result. So first thing I'm doing is splitting my data into training and testing, and I'm printing the shape of my training and printing the shape of my testing. So the number of records in training is 124, and the number of records in testing is 54. In this instance, I'm picking support vector classifier. And these are my hyperparameters I'm choosing: kernel equal to linear, my C equal to 50, gamma equal to auto, and then also specifying degree equal to 4 and decision function shape equal to OVR, one versus rest. That's what it means. So then I'm training the model, and then I'm checking the score of the model. So when I run this, it gives me the score of 87%. That's pretty good. So that means 87% it got right with this, with these hyperparameters: linear, 50, and auto. But what if I change this to something else? Let's see if I can increase that. So change from linear to poly. Okay, then change 50 to 20. Change gamma to auto, or to scale. So try different combination, because your kernel can take any one of these values. Likewise, your C can take any one of these values: 10, 20, 30, 40, 50. I'm just picking up any values right now. Gamma can take any one of these values. So in this particular instance, how many combinations of hyperparameter would you try? Well, the answer is you have 4 over here. So that would be 4 multiply by, you will have 5 over here, 5 values of C. So that will be 5. And how many gamma you have? 2 gammas. So it's going to be 2. So 4 times 5 times 2. And the answer is 40. So you would run this cell 40 different times by trying every single combination of that. And this can take a long time if done manually. Now, in the second approach, I will use k-fold cross-validation. In this particular instance, I will be manually supplying my models with different hyperparameters to the cross-validation function. In this case, I'll be using 5-fold cross-validation. So import your cross-validation score function, import your SVC, and I'm also importing NumPy so I can calculate the average of my score. So in this case, I'm supplying SVC to the cross-validation score. In this case, I'm saying my kernel equal to linear and my C equal to 1 and gamma equal to auto. So these are my hyperparameters that I'm choosing at this instance. I print the score, and I'm also printing the average of that. So for each run, it prints out the score, then it also prints out the average, and the average is 0.86. All right, let's do it again now. This time I'm supplying my hyperparameter kernel equal to RBF, and my C is equal to 10, and my gamma equal to auto. When I run this and I print my average score, comes out to be 77. Well, actually went down. It was high over here. It actually went down. Well, what about this one? In this case, my kernel equal to RBF, my C equal to 20. I have changed my C and my gamma equal to auto. So I print again my average, and my average comes out to be 76 point, and I can just keep going like this. So I just ran above on few hyperparameters. So from these limited results, from this 1, 2, and 3, from these three results, I can see that this one is giving me the best result. In other words, when your kernel equal to linear and your C equal to 1 and your gamma equal to auto, that seems to me giving me the best result right here. And now let's use approach number 3. In this instance, I'll be using grid search cross-validation. So the grid search cross-validation does exactly the same thing as above, but it does in a single line of code. So in this case, you just import grid search CV, and in this function, you supply your SVC gamma equal to auto. That means your gamma is not going to change. And then you're supplying your C. You're saying C can take value 1, 10, and 20. And your kernel is going to be RBF or linear. So you're specifying that your kernel can take all these two values. And then you're supplying your CV equal to 5. And then you train this model right here. So this model gets trained. Then I want to see the result. I want to see the result in the form of a data frame. So you put it inside data frame and you print your data frame, and this gives you the result right here. It gives you mean fit time, standard deviation of your fit time, your average value of your score time, standard score. It gives you all these parameters right here. Parameter kernel, parameters, split zero test scores. So it gives you a test score for each one of the splits. In this case, since this is a five-fold cross validation, you're going to have 5 different splits: split 0, split 1, split 2, split 3, and split 4. Okay, so the most important ones, the most important columns over here are param C, which is parameter C, and parameter kernel, and mean test score. So let's filter them out. So in this case, I'm printing those particular columns, and these are the corresponding values right here. So look at this test score, and you can see that just by looking over here, the best result you're getting is over here, this one. So in this particular instance, your C equal to 20, and your kernel equal to linear, and your test score is 89. So this is 89%. So this 89% is the best one among all these test score. So you can also print out your test score directly, sorry, your best parameter directly by model gs.best params. When you print it out, that gives you C equal to 20, and your kernel is linear. That would be this right here. If you want to see the best score, you can also access the best score. In this case, this is your best score, which is exactly same as this. And now let's use our grid search CV on different models with different hyperparameters. So in this particular instance, I'm just picking up three classifier models. I'm picking SVC, I'm picking random forest classifier, and I'm also picking logistic regression model. And I want to see among these three models, which is the best model. And I also want to try different hyperparameters on each one of these models. So for my SVC, the hyperparameter that I want to try is C as 1, 10, and 20, and my kernel I want to try as RBF and linear. Well, in the case of random forest classifier, the hyperparameter I want to try, in other words, an estimator, that would be 1, 5, and 10. And for the logistic regression, I want to try my C as 1, 5, 10. Okay, so these are my model parameters right here. So these are my three models: SVM, random forest, and logistic regression. Step number 2. Now you perform grid search CV on above three models. So in this case, you can actually do manually, or you can run a little for loop. So in this instance, I'm just running a for loop. So I'm going through each one of the models, and I'm running grid search on each one of them. And after that, I'm appending whatever result I'm getting. I'm appending their scores in the scores data set, sorry, in the scores list right here. And then I'm actually putting my scores in a data frame. So this way I can see my data frame nice and neat. So when I run this, it gives me this result right here. So in this particular instance, you can see that your best score is going to be this one right here, which is 0.89. In other words, 89.38% of your results it has an accuracy of 89.38%. So that tells me that your model SVM among random forest and logistic regression is the best model. So SVM is the best model, and your best hyperparameter is this one right here, C equal to 20, and your kernel equal to linear. So this is your best model with the best hyperparameter. And now approach number 4. We use randomized search CV. So use randomized search CV to reduce the number of iteration with a random combination of parameters. So it's not going through every single hyperparameter. It's just randomly picking up some hyperparameters and just trying to see which one gives you the best result. This method is useful when you have too many parameters to try, and your training time is going to take longer because you have so many hyperparameters. This one, it helps reduce the cost of computation. And by the way, it does not guarantee the best model because you're randomly picking up hyperparameters over here. So in this case, I'm picking up SVC, and I'm also calling this method randomized search CV. So inside this randomized search CV, you supply your model right here, and then you supply your hyperparameters. So your randomized search CV is going to randomly pick up C's and randomly pick up a kernel from here and try to find out which one is the best model. In this case, you supply CV equal to 5, supply your return train score equal to 4, and number of iterations, how many iterations you want. In this case, let's say I just want 2. So you train your model, and then whatever result you get, you convert that into data frame so that this way I can see my result nice and neat. And by the way, I only want to know parameter C, parameter kernel, and mean test score. That's the only one I care about for. So when I run this, it gives me this result right here. So you can see that the best test score is right here, this one. So for that, your C was 10 and your kernel is linear. Conclusion, your best SVC model hyperparameters are C equal to 10 according to the randomized search CV. Now, by the way, just on a side note, this result may be different in your case because when you run this, it may pick up a different combination. And in that particular instance, your mean test score may be different. So your this thing will change and this thing will change. So also your result may be different from the grid search CV because in this particular instance, your randomized search is randomly picking up hyperparameters. It's not picking up every single hyperparameter. So that's why your result may be different from your grid search CV.